Hi and welcome to Maths class. Today we're looking at similar triangles and we are going to get to tests for similarity, but not in this video, that'll be in the next video. For now, what we're going to learn about is what are similar triangles and just sort of informally how can we identify them and how can we use them. So first of all, similar. This is an English word that we use all the time to describe two things that are sort of the same, but there's something different about them. And that's basically the case with similar triangles. So similar shapes are shapes that have the same shape but different size. And similar triangles have the same shape but different size. And what I've got there is an example of a pair of similar triangles. I'm going to take this away and you can see, just fits in on my screen, that I've got one big triangle and one small triangle, and I've lined up the small one right inside the big one so that you can actually see that they're the same shape. But what we're really looking for is that similar triangles have all the angles the same. So let's test that. If I pick this guy up and I slide him right into the corner there, I can see that those angles line up. And if I put him up there, I can see that those angles line up as well. And the final angle, well, that was just the corner of the piece of paper, so it'll be 90 degrees. And yes, they are the same. So all the angles are the same. But similar triangles have another special property, and that is that when you increase the size, going from this small one to this big one, the ratio is all the same. And in this triangle, the ratio is 2, and I'll show that to you. When I take one side of this triangle and I line it up against the other one, and I'm just going to mark that point. Oh, you can't see that. Let me try that with a better colour. I'll mark that point. Now, if I take the small size and line it up here, basically that means that this hypotenuse here on the pink triangle is double the blue triangle. So the ratio is 1 to 2, right? For every 1 on the small triangle, I'm going to have 2 on the big triangle. And this works for any length in the triangle at all. So let's test the bottom side. Let's line it up there. And then I mark it right where the edge is, right there. And then let's move that over. And it's the same again. Every one of these lines up to 2 on the pink triangle. And you'll see that it'll be the same on the final triangle. Let's mark it on the final side, Mark it there. That's one of these blue lengths. If I push that up, you'll see it goes all the way to the tip. So lengthwise, only for length, this blue triangle, every one of this blue triangle is every 2 of the pink triangle. And we can use that fact to find missing sides on a similar triangle. So what we're talking about is a thing called scale factor. And scale factor tells you the size of one triangle compared to the other triangle. And quite often when we do our first examples, we'll be going from a smaller triangle to a bigger triangle. So let's have a look at these two triangles. This is a 3, 4, 5 triangle. This is an old friend. We know this guy. This is a Pythagorean triad, which means it's a right-angled triangle with all whole number sides, which is very useful. So this is the same triangle, but enlarged. But by how much has it been enlarged? What I'm going to do is just compare corresponding sides. Now remember, in congruent triangles we talked about corresponding sides. I'm not going to link this 3 with this 8 because they're not corresponding. This 3 is the shortest side on this triangle and this 6 is the shortest side on this triangle. So these guys are corresponding. And when I go from 3 to 6, I had to multiply by 2. Look, when I go from 5 to 10, I have to multiply by 2. And when I go from 4 to 8, I also have to multiply by 2. So that means that my scale factor is 2. Okay, so I've found the scale factor. So if I had a missing side, if I didn't know this 8, I could go, well, what's this going to be? It's going to be times 2 of this 4. So 4 times 2, and that would give me the 8. So now let's look at example 2. I've got another one of my Pythagorean triads, but just to make it really clear, I've marked in that all the angles are the same because that's how I know they're similar. These angles are the same, these 2 angles are the same, and these are the same. And that also helps orient me and work out which my corresponding sides are. I know that this 5 corresponds to the 15 because they're both in between the right angle and the curve, the angle marked with a curve. And I know the 13 corresponds to the x, partly because they're both hypotenuse, but because they both run between the curve and the dot angle. All right. Okay, so I need to work out the scale factor, and this is how I do it. Scale factor is going to equal, I'm going to do the length on triangle 2 divided by the length on triangle 1 in a corresponding pair. And that gives me 3. That's my first step to finding the missing side. And now what I know is that 3 is also going to equal this side here divided by this side here, x divided by 13, because it's going to be in the same ratio. So this divided by this has to give me the same answer as this divided by this, just like it did up here. 10 divided by 5 is 2, 8 divided by 4 is 2, 6 divided by 3 is 2. That's how I know they're similar triangles. All right, now this is an equation that I can rearrange, and I didn't quite leave myself enough room, but x is going to equal 13 times 3, which is going to equal 39. Obviously, my diagram is not to scale because this is not drawn to be 3 times longer than this, but that doesn't matter, right? We just look at the numbers. We don't look at approximately what size we think it should be. We just do the calculations. All right, now I've got a more complicated example to show you. This one gets a little bit tricky. If you want to, it might be a good idea to pause the video here and go and do some of the straightforward ones, and then come back and watch this example once you start to get to some of the harder problems. Because what I have here, I definitely have 2 similar triangles. Let's test first to see how we know. I know that these lines are parallel. Okay, so what that tells me is if I draw a line through my parallel line, remember the things that we know about lines and parallel lines? These are called corresponding angles, so they are equal. And these are also called corresponding angles, so they are equal. And this angle here is common to both triangles, therefore I know that that's equal. So I know that they're similar triangles. The easiest way to deal with triangles like this, when you've got one kind of nested inside the other, don't leave it like that. Redraw it and redraw all the information that you have. There's my big triangle, there's my small one. It doesn't really matter if it's not to scale. What matters is, what's the length of this side? It's this total length here. Don't get fooled by the 2, it's actually 5. And what's this length here? It's 3. All right, now let's look at the x and the 4. This side I'm going to ignore because I don't know anything about either of them. But let's look at the x and the 4. This is definitely a 4 here. Now, don't be fooled by the 3 and the 4. This is not a 3, 4, 5 triangle because 4 is the longest side on this triangle. Okay. What have we got here? The x is just this part here. It's not the entire length. So this side here is x plus 4. So now what I'm going to do is I'm going to write an equation linking the ratios of the 2 sides. I might just call this triangle A and triangle B. All right. So what I'm going to do is I'm going to go biggest divided by smallest. A is bigger than B. So on triangle A, I've got a 5 and a 3. So the ratio is going to be 5 over 3. And on the longer side, On triangle A, I've got an x plus 4, and on triangle B, I've got a 4. So I'm going to have x plus 4 divided by 4 if I do A over B as my ratio. Be really careful to make sure you always put the same triangle on top. It actually doesn't matter which way you go. Just pick one, although it's easier here to have the unknown on the numerator, which is why I chose A as my numerator. But if I went B over A, it would make it equally true that these two ratios have to be the same. Because 5/3 is the ratio of the two triangles. If I multiply this 3 times 5 over 3, 3 times 5 over 3, I get, well, those 3's will cancel, and I'll get 5. So 5/3 is the number that I multiply the lengths on this triangle by in order to get the lengths on this triangle. All right? Therefore, 5/3 has to equal x plus 4 over 4 because that's the ratio of these two sides, this one divided by this one. If I multiply 4 times x plus 4 over 4, let's do that, 4 times x plus 4 over 4, these 4's will cancel and I'll get x plus 4. What does that show? That just shows that this is the ratio of the two triangles. If I multiply 4 by this number, I get this number. So I've got two versions of the ratio. I've got 5/3 and I've got x plus 4 over 4. But there's only one pair of triangles, so there's only one ratio, which must mean that these two are equal. Now I've just got an equation that I need to solve. Looks like I'm going to have some fractions, which is not my favourite thing, but I can deal. So let's solve this. I'm going to have 4 times 5/3 equals x plus 4 because I multiplied both sides by 4 in order to eliminate that denominator. I don't like denominators underneath my unknown. Let's work that out. That's 20 over 3 equals x plus 4. Now I just need to subtract both sides of my equation by 4. So that's 20 over 3 minus 4 is going to equal x plus 4 minus 4, which is nothing, so just x. Now I just need to calculate this. So let's rewrite 4 as a fraction over 3. 20 over 3 minus 12 over 3 equals x. So I've run out of room. X equals 8 over 3. So we've calculated x, which is what, well, it doesn't say, there's no words, but imagine that the words of the question were find x. We have done that. We've calculated that x is 8 over 3, so we've finished the question. All right, so that's the end of the video on scale factor. The next video is going to talk about tests for triangle congruence. Tests for similarity. The next video is going to talk about triangle tests for similarity.